Hello everyone, my name is Suryans Kumar and I am currently a student of Gopal Narayan Singh University. Today I am going to walk you through an important data structure called linked list. We are explore what they are, how they work, their types, key operations and real world applications. By the end of this presentation you will have a solid understanding of how linked lists operate and why they are so useful in computer science. Introduction to linked list. So, what is linked list? A linked list is a linear data structure where elements called nodes are not stored in contiguous memory locations. Each node contains two parts, the data and the reference to the next node in the sequence. Unlike arrays, linked lists are dynamic, which means they can grow or shrink in size during runtime, making them very flexible. But why do we use linked lists? The primary reason is efficient memory uses and the ability to perform insertion and deletions without reorganizing the entire data structure. This makes them ideal for applications where frequent addition and removal of data are required. Types of linked list. Now let's talk about the types of linked lists. Singly linked list. In this type, each node points only to the next node in the sequence. It's the simplest form of linked list. Doubly linked list. Here each node has two references, one to the next node and one to the previous node. This allows traversal in both directions. Circular linked list. In this variant, the last node points back to the first node, creating a circular chain. Each type has its own use cases and benefits, which we will explore further. Basic operations. Linked lists support four primary operations: insertion, adding a new node to the list; deletion, removing a node from the list; searching, finding a specific element within the list; traversing, accessing each node sequentially. The key advantage here is that these operations can be done efficiently without recognizing the entire structure, unlike arrays. Comparison with arrays. You might be wondering how linked lists compare with arrays. Here a quick breakdown. Advantages. Linked lists have a dynamic size, which means you don't need to know the size of list beforehand. Insertion and deletion are easier and more memory efficient. Disadvantages. They do not allow random access, meaning you have to traverse the list to get to a specific element. Extra memory is required for storing pointers. Real world applications. Linked lists are not just a theoretical, they are widely used in practical applications. Music and video playlist where each track is linked to the next. Undo mechanism in software where actions are linked sequentially. Hash tables use linked list for collision handling through separate chaining. Code example. Now let's look at a simple implementation of a singly linked list in C. First, we define a structure for a node which contains two main components: an integer data field to store the value, a pointer to the next node named next. Next, we create a function to allocate memory for a new node, initialize its data and set its next pointer to null. In the main function, we create three nodes and linked them together. Here, the first node stores the value 10 and its next pointer points to the second node, which stores 20, and so on. Finally, we traverse the list to display its content. That concludes our walkthrough of linked list. I hope you now have a clearer understanding of what they are, how they work, and where they are applied. Thank you.